June 8, 1944. 9:23 a.m. Arromanches, Normandy. Hauptmann Friedrich Weber stands with 200 other German prisoners on the beach, hands behind his head, watching the English Channel. He's an engineer, coastal fortification specialist, spent 18 months building the Atlantic Wall, calculated stress loads for concrete casemates, supervised the installation of 88mm guns in reinforced bunkers with 6-foot-thick walls. He knows fortifications. He understands defense, which is why what he's seeing makes no sense. Massive concrete structures, 5 stories tall, bigger than apartment buildings, are being towed across the channel. Dozens of them, moving slowly, inexorably toward the French coast. Tugboats strain against the weight. The structures ride low in the water, gray and monstrous. Weber has seen these before. In intelligence photographs, British harbors, fall of 1943. The Abwehr analysts dismissed them. Anti-submarine barriers, they said, or perhaps devices to block captured ports, denying them to German forces. But now, watching them approach, Weber understands. His hands start to shake. "Mein Gott," he whispers. The British guard glances at him. "What's that, Fritz?" Weber doesn't answer. He's calculating dimensions, estimating displacement, recognizing the engineering brilliance of what he's witnessing. These aren't submarine barriers, they're caissons, breakwaters, the foundation of an artificial harbor. The Allies aren't trying to capture a port, they're building their own. Here, on an open beach, in water that shouldn't support permanent structures, it's impossible, except it's happening right in front of him. Weber turns his head, looks inland. 2 days ago, he was manning a fire control position at WN 62, one of the strongest fortifications on the Normandy coast. 6-foot concrete walls, 8mm guns with overlapping fields of fire, mines, obstacles, everything positioned for maximum defensive efficiency. The Americans overran it in 6 hours, and now this. How? Weber asks, still staring at the concrete giants crossing the channel. "How did we not know?" The British guard shrugs. "Jerry intelligence isn't what it used to be, mate." Weber closes his eyes. 2 years, 15,000 bunkers. Millions of tons of concrete poured into the Atlantic Wall, all predicated on a single assumption. The Allies must capture a port to sustain an invasion. Control the ports, control the invasion. That was the entire defensive philosophy. And in one stroke, these floating concrete boxes, it's all rendered meaningless. The Atlantic Wall still stands. Every bunker, every gun, every meter of reinforced concrete exactly as designed. But it doesn't matter. Not because it wasn't strong enough, because strength wasn't the answer. August 13th, 1942. 2:30 p.m. Führer Headquarters, Rastenburg, East Prussia. Adolf Hitler spreads a map across the conference table. The Atlantic coastline from Norway to Spain marked in red. 4,000 kilometers of coastline. One massive problem. "The British will invade," Hitler says. His finger traces the French coast. "Not this year, but soon. They must." Stalin demands a second front. Churchill needs to show progress. Roosevelt needs to justify sending American boys to Europe. Across the table, Albert Speer, Minister of Armaments, Field Marshal Gerd von Rundstedt, Commander-in-Chief West, General Alfred Jodl, Chief of Operations, Admiral Wilhelm Canaris, Head of Military Intelligence. Speer looks at the map, at the enormous coastline, at the impossible task Hitler is about to propose. "The Dieppe raid," Hitler continues, "taught us something valuable. The British threw 5,000 men at a fortified port, lost more than half, achieved nothing. The lesson is clear: fortified ports cannot be taken by direct assault." He pauses, lets that sink in. "Therefore, the invasion, when it comes, must capture a port." Without port facilities, they cannot sustain an offensive. Ships cannot unload on open beaches, not in sufficient quantities, not in channel weather. They need cranes, piers, warehouses, sheltered anchorages. Von Rundstedt nods slowly. If we control the ports, we control whether an invasion succeeds. Exactly. Hitler's hand slams the table. We will make the Atlantic coast impregnable, every port a fortress, every beach a killing ground. We will build a wall of concrete and steel that no enemy can breach. Speer does mental calculations. He knows what's coming. Hitler turns to him. I want 15,000 fortifications built by April 1943, bunkers for 300,000 men, the entire coast from Norway to Spain. Silence. Speer clears his throat. Mein Führer, I'm not certain we can achieve even 40% of that target in that time frame. You will. Hitler's voice allows no argument. This must be done with frantic energy. Frantic, do you understand? The organization Taut will mobilize every available worker. Construction continues day and night. The defense of the Reich depends on this. Hitler's finger stabs the map at specific points. Priority 1, U-boat bases. Brest, Lorient, La Rochelle, Bordeaux. These must be indestructible. Without the submarine campaign, we lose the Battle of the Atlantic. Priority 2, major ports the enemy needs. Cherbourg, Le Havre, Boulogne, Calais. These must be fortresses, garrisoned, provisioned, capable of holding out for weeks. Priority 3, Channel Islands. British territory held by German forces. They cannot lose face by abandoning these. Therefore, they are strategic. Priority 4, open beaches suitable for landing. Every approach mined, fortified, defended. Speer is making notes, calculating. Concrete requirements, labor needs, steel for reinforcement, transportation, logistics. The numbers are staggering. Hitler isn't finished. Each strong point will house 30 to 70 men, machine guns, anti-tank guns, heavy artillery, overhead cover sufficient to withstand naval bombardment and aerial attack. Interlocking fields of fire. The enemy will not cross these beaches. He will die on them. Von Rundstedt studies the map. A coastal wall, like the West Wall on our frontier, but longer. Much longer. The Atlantic Wall, Hitler says. Impregnable. Canaris shifts uncomfortably. The British have proven adept at innovation. Commando raids suggest they're developing specialized equipment. We consider nothing but making the wall strong enough. Hitler's interruption is absolute. Let them innovate. Let them scheme. Concrete walls defeat innovation. This is not complicated warfare, gentlemen. This is simple mathematics. They must land supplies. To land supplies, they need ports. We deny them ports. Therefore, they cannot invade. Or if they try, they will fail within days as their ammunition and fuel run out. The meeting continues for another hour. Speer receives his marching orders. Organization Taut will expand operations. Forced labor from occupied territories. Specialists from German construction firms. Round-the-clock shifts. As the officers file out, Speer lingers. Mein Führer, one concern. The concrete requirements are extraordinary. This will impact other construction projects. Aircraft factories, submarine pens, V-weapon sites. The Atlantic Wall is the priority, Hitler says. If the invasion succeeds, nothing else matters. No factory in Germany will save us if Allied armies are marching through France. Build the wall, Speer. Build it properly. Build it to last 1,000 years. Speer nods, leaves, returns to Berlin to begin the impossible task. Within weeks, Organization Taut mobilizes across occupied Europe. The Atlantic Wall begins to rise, March 15, 1943. 7:00 a.m., Colleville-sur-Mer, Normandy coast. Jean-Pierre Rousseau reports for his shift at the construction site marked WN62 on German planning documents. Wider stands Nest 62. Resistance Nest 62. He's French, civilian, drafted into mandatory labor service for organization taught. He's a mason by trade, which makes him valuable. Concrete work requires skill. The Germans need skilled workers. The alternative to working is a labor camp in Germany, or worse. So Jean-Pierre mixes concrete. The construction site sprawls across the bluff overlooking the beach. Wooden scaffolding, piles of steel reinforcement bars, cement bags stacked under tarps. A diesel generator rumbles, powering lights and equipment. 300 workers on this site alone, working 12-hour shifts, 7 days a week. The foundation was poured last month. Massive concrete slab, 80 centimeters thick. Now they're building the walls. Franz Huber, the German site supervisor, briefs the morning shift. Today we pour the southern gun casemate wall. 3 meters of concrete, 2-meter thickness. The shuttering is in place. The rebar cage is assembled. We have exactly 8 hours before the concrete begins setting. No delays, no mistakes. The workers nod. They've done this before. Different position, same process. Jean-Pierre joins the team at the concrete mixer. Sand from local quarries, gravel, cement from Germany, water. The proportions are exact. Mix it wrong, the concrete fails. The entire structure becomes worthless. The mixer churns. Workers push wheelbarrows up wooden ramps to the scaffolding. Pour concrete into the wooden forms that will shape the wall. Other workers use vibrating tools to eliminate air pockets. Air pockets mean weak spots. The Germans don't accept weak spots. By noon, the wall is half poured. Jean-Pierre takes his break, sits on a pile of lumber, eats black bread and cheese. Looks out at the beach below. It's beautiful. Golden sand, blue water. Before the war, families came here on holiday. Children built sandcastles. Couples walked along the shore. Now it's a construction site for the largest fortification system in history. Below the high tide line, other workers are installing obstacles. Belgian gates, steel frames designed to rip the bottom out of landing craft. Hedgehogs, welded steel beams angled to tear hulls. Wooden stakes topped with teller mines. Thousands of obstacles, the entire beach becoming a trap. "Back to work," Huber shouts. The afternoon shift continues. More concrete, more wheelbarrows. Jean-Pierre's arms ache, his back screams, but the work continues. By 6 p.m., the wall is complete. Smooth concrete surface, perfect thickness. The wooden shuttering will stay in place for days while the concrete cures. Huber inspects the work, runs his hands along the surface, checks measurements. "Acceptable," he finally says. High praise from Huber. Over the following weeks, WN62 takes shape. 4 gun positions. 2 75mm guns in reinforced casemates with interlocking fields of fire along the beach. 2 50mm anti-tank guns covering the approaches. Mortar pits, machine gun positions in Tobruk mounts, captured French tank turrets set into concrete rings. The casemate roofs are engineering marvels. 6 feet 7 inches of concrete. Steel I-beams running across the ceiling, spaced precisely. Metal plates fitted between the beams. This prevents spalling. When a shell hits the roof, the vibration can shake loose concrete fragments inside. The steel plating catches them, protects the gun crew. Every design element serves a purpose. Fire embrasures precisely angled for maximum field of fire while minimizing exposure. Ammunition storage bunkers with blast walls, ventilation systems that filter gas attacks, steel doors that seal compartments, escape tunnels for the garrison if positions become untenable. By May 1943, WN62 is operational. It's one of 14 resistance nests between Colville and Virville-sur-Mer. Together they defend 6,800 meters of coastline. WN60 and 61 cover the eastern sector. WN62 anchors the center. WN 64 through 73 defend the western approaches. Each position supports its neighbors with overlapping fire. An enemy attacking WN 62 will be engaged from WN 61 and WN 64. No gaps, no blind spots. Field Marshal Erwin Rommel arrives in January 1944 to inspect the defenses. Jean-Pierre watches from a distance as the famous commander walks through WN 62. Rommel examines the gun positions, tests firing arcs, questions the garrison commander about ammunition supplies, communication systems, fallback positions. Then Rommel walks down to the beach, studies the obstacles, orders more mines, more steel, more wire. The enemy must be stopped at the water's edge, Rommel tells his staff. Not on the beach, not in the bluffs, at the water. Every meter they advance increases their chance of success. We give them nothing, not 1 meter. Additional work crews arrive. More obstacles. The coverage extends further below the high tide line. Belgian gates every 30 meters. Hedgehogs clustered in groups. Stakes with mines. Some stakes angle to impale landing craft. Others vertical to tear hulls. At high tide, most obstacles are invisible. Submerged. Waiting. By April 1944, the Normandy coast bristles with defenses. 15,000 fortifications along the Atlantic Wall, from Norway to Spain. Every major port fortified, every beach defended. The strongest section is here, Normandy, the closest point to England, the obvious invasion route. Rommel stands on the bluff at WN 62 in early May, looks out at the beach, at the obstacles, at the mines, at the guns. They will come here, he says, and they will die here, in the water, on the beach, against walls they cannot breach, with weapons they cannot carry ashore. He pauses, looks at the channel. Gray water, white caps, 20 miles to England. Every military academy teaches that invasion forces need ports, need facilities to unload supplies. Our wall makes the ports untakeable, therefore. He doesn't finish the sentence. He doesn't need to. The logic seems airtight. Control the ports, control the invasion. The Atlantic Wall stands ready, impregnable. May 30th, 1942, 10:00 p.m., 10 Downing Street, London. Winston Churchill sits in his war room, cigar burning, whiskey at hand, staring at maps of the French coast. Around the table, Admiral Lord Louis Mountbatten, Chief of Combined Operations. General Frederick Morgan, recently appointed planning staff. Vice Admiral John Hughes Hallett, Brigadier Charles Hayden. They've been at this for 3 hours. The question on the table, how do you invade France? The Americans want action in 1943, Churchill says. Stalin demands a second front immediately. The combined chiefs have approved Operation Roundup, landings near Calais next spring. He taps the map. Here, the shortest route, the obvious choice. Morgan looks skeptical. The Germans know it's obvious. Their strongest fortifications are in the Pas de Calais. Every beach approach is fortified, and more critically, he pauses, we need a port. Without port facilities, we cannot sustain an offensive. Dieppe taught us that, Mountbatten adds quietly. The room falls silent. Dieppe, August 19th, 1942, just months ago. 5,000 Canadian troops attacking a fortified port. Frontal assault. The casualty lists are still coming in. 60% casualties, nearly 1,000 dead, 2,000 captured, complete disaster. But also a brutal lesson, fortified ports cannot be taken by direct assault, not against prepared defenses, not with the weapons available. Churchill exhales cigar smoke. Analysis? Morgan spreads logistics documents. An invasion force requires 600 tons of supplies per division per day. In the first week, we'll have 10 divisions ashore. That's 60,000 tons every day. We need cranes to unload ships, piers for vessels to dock, warehouses for storage, facilities to transfer cargo from ships to trucks and trains. Which means we need a port, Churchill says. which means the Germans know we need a port, Mountbatten counters. Therefore, every port is fortified, Cherbourg, Le Havre, Boulogne, Calais, all designated as fortresses. Hitler has ordered them held to the last man. Hughes Hallett leans forward. Even if we capture a port, the Germans will demolish the facilities before surrendering. They'll sink ships in the harbor, blow the cranes, destroy the piers. We're looking at weeks, possibly months, before we can make a captured port operational. By which time, Morgan continues, the invasion force has run out of ammunition and fuel. Game over. Churchill stares at his cigar, thinking. Can we land supplies over open beaches? Small quantities, Morgan says, but not enough, not for 10 divisions conducting offensive operations. Channel weather is unpredictable. Storms can halt beach operations for days. We'd need perfect weather for weeks, which we won't get. Churchill stands, paces. Everyone in the room knows this look. The Prime Minister is working through a problem. Finally, he turns back to the table. Gentlemen, I put this to you. If we cannot capture a port, can we take one with us? Silence. I'm sorry, Prime Minister. Mountbatten looks confused. An artificial harbor, Churchill says. Floating piers, breakwaters to create sheltered anchorage. Everything a port provides, but portable. We build it in England. We tow it across the channel. We assemble it on the invasion beaches. More silence. Prime Minister, Hughes Hallett says carefully, such a thing has never been done. The engineering challenges are enormous. The channel tides alone are solvable, Churchill interrupts. Every problem is solvable with sufficient ingenuity. We put this to the engineers. Tell them what we need. Let them determine if it's possible. Morgan makes notes. Requirements? Capacity to handle ocean-going vessels, Liberty ships of 10,000 tons or more, facilities to transfer cargo efficiently, protection from weather, breakwaters probably. It must be mobile, assembled rapidly, and robust enough to survive channel conditions. Churchill sits back down, relights his cigar. Gentlemen, the Germans are building the strongest coastal defenses in history. They're pouring millions of tons of concrete into fortifications. They believe correctly that we need ports. Therefore, they fortify every port. He leans forward. We change the equation. We remove ports from the problem. We bring our own. This is how we win. Not by attacking strength, by rendering strength irrelevant. The meeting continues past midnight. Questions pile up. Feasibility studies are ordered, engineers will be consulted, Admiralty architects will review designs, but the seed is planted. Project Mulberry begins. October 1943, Portsmouth Dockyards, England. John Mowlem, chief engineer for the Phoenix Caisson project, stands before the largest concrete structure he's ever designed. It looks like a building. 5 stories tall, 60 meters long, 18 meters wide, 18 meters high, except it's hollow and it floats. The calculations work, he tells his team. In theory. In theory, his deputy Harold Wills echoes. Sir, we've never built anything like this. The stress loads when it's being towed through rough seas are within acceptable parameters, barely. Mowlem points to blueprints spread across a makeshift table. The Phoenix caissons are the foundation of the entire project. Without these, there's no breakwater. Without breakwaters, there's no protected harbor. Without a protected harbor, the invasion fails. Wills looks at the structure taking shape in the dock. Workers swarm over wooden scaffolding. The sound of hammers, saws, generators fills the air. We're building 146 of these, Wills says. Different sizes, but all the same basic principle. Concrete boxes that float across the channel, get positioned, then flood to sink into place. Mowlem nods. The largest will displace 6,000 tons. That's heavier than a destroyer. and we're towing them at walking speed across one of the most treacherous bodies of water in the world. If one breaks loose in a storm, it won't. The engineering is sound. The concrete mix is correct. The compartmentalization ensures even if some sections flood prematurely, the structure remains stable. Mollem walks around the partially completed caisson. Workers are pouring concrete for the inner walls. The structure is divided into compartments. When it's time to sink the caisson into position, specific compartments will be flooded in sequence. This ensures the Phoenix settles level into the seabed. "How long for this one?" Mollem asks. 3 weeks for initial construction, another 2 weeks for curing. Then we flood the dry dock, float it out, and tow it to the assembly area. We need all 146 ready by May. Wills does math in his head. We'll need multiple construction sites, every suitable dock in southern England. Then requisition them. The Admiralty has given us top priority. Work continues around the clock. Portsmouth, Southampton, Dover, Bristol, anywhere with appropriate facilities, Phoenix caissons take shape. Simultaneously, other components are under construction. The bombardons, floating steel breakwaters. Cruciform cross-section, 200 feet long. These will form the outer barrier, breaking the force of waves before they reach the main harbor. Steel fabrication plants work overtime producing the sections. The whales, floating roadways, 80-foot steel sections that connect ships to shore. These must rise and fall with channel tides, 23 feet of range. The engineering is complex, telescoping sections, flexible joints, strong enough to support tanks and trucks. The Lobnitz pierheads, adjustable floating piers where ships can dock, 200 feet long, 60 feet wide, telescopic legs that extend to the seabed, keeping the pier stable while allowing it to rise and fall with tides. At a planning meeting in December 1943, Mountbatten reviews progress. Status? Phoenix caissons 40% complete, bombardons 30%, whales and pierheads on schedule. The critical path is the Phoenixes. Everything depends on those. And the Germans? Intelligence Officer Commander Ian Fleming, yes, that Ian Fleming, provides the assessment. Abwehr has photographed Phoenix construction at multiple sites. Their interpretation is... He pauses. Fascinating. They believe these are either anti-submarine barriers to protect harbors, or devices to block captured ports by scuttling them in harbor entrances. They don't suspect the true purpose. No, sir. The concept of an artificial harbor is apparently too audacious for German military thinking. They assume we'll attack ports directly. The idea that we'd build our own has never occurred to them. Mountbatten allows himself a small smile. Admiral Canaris is missing the biggest intelligence failure of the war, and he doesn't even know it. By April 1944, components are ready. 146 Phoenix caissons, 70 bombardons, miles of whale sections, 20 Lobnitz pierheads, plus supporting equipment, tugs, anchoring gear, assembly crews, 2 complete Mulberry harbors, Mulberry A for the American beaches, Mulberry B for the British beaches. Combined capacity, enough to support 30 divisions conducting active operations. The logistics are staggering. The components are staged in assembly areas along the English coast. Crews are trained, towing procedures rehearsed, assembly sequences memorized. This will be the largest engineering project attempted during active combat operations. If it works, it changes the invasion calculus completely. If it fails, the invasion might fail with it. June 7, 1944, 6:00 a.m. English Channel. Captain Robert Harrison stands on the bridge of the tugboat HMS Destiny watching the tow cable stretch ahead into morning mist. At the end of that cable, Phoenix caisson B-24, 5 stories of concrete, displacing 4,000 tons moving at 4 knots through choppy seas. Like towing a bloody office building, his first mate mutters. Harrison doesn't disagree. The Phoenix wallows in the swells. It's low in the water, deliberately. The design ensures stability. But that doesn't make it graceful. Around HMS Destiny, dozens of other tugs perform the same duty. The sea is full of Phoenix caissons making the crossing. Some left yesterday, others this morning. The schedule is precise. Each Phoenix must arrive at specific times for the assembly sequence. ETA Arromanches? Harrison asks. 1,300 hours if this weather holds. And if it doesn't? Then we're towing a 4,000-ton paperweight in a storm, sir. The first Phoenixes left England yesterday morning, immediately after the beaches were secured. The plan called for rapid deployment. Get the harbors operational as quickly as possible. Every day of delay means supplies coming in at lower rates. Harrison has seen the logistics estimates. 60,000 tons of supplies needed daily once the buildup begins. Without the Mulberries, that's impossible. Beach operations can handle maybe half that rate, and only in good weather. By mid-morning, the French coast is visible. Smoke rises from inland fighting. The naval bombardment has stopped. Most of the fire support ships have withdrawn. The invasion is 2 days old. Allied forces are pushing inland from all 5 beaches, but they're still within range of German artillery, which means the assembly crews will be working under potential enemy fire. Signal from headquarters, the radio operator calls. Phoenix B-24 to position Baker 7. Assembly crews standing by. Harrison adjusts course. The positioning must be exact. The Phoenixes form a breakwater. Each caisson must interlock with its neighbors. A gap in the line means the breakwater fails. They arrive at position by early afternoon. Harrison's crew attaches buoys, marks the precise spot. Then engineers on small boats swarm around Phoenix B-24. Flood sequence beginning, one engineer shouts up. Valves open. Seawater floods into Phoenix B-24's compartments. Slowly, precisely, the caisson settles. The timing is critical. Flood too fast, it might tip. Too slow, the tide changes and the positioning is wrong. 20 minutes later, Phoenix B-24 sits on the seafloor. Top 2 stories still above water. Exactly as designed. Harrison watches engineers scramble over the Phoenix, checking alignment, verifying position. Other Phoenixes are settling into place nearby. The breakwater is taking shape. Job done, his first mate says. First of many, Harrison replies. We've got 3 more to tow today. HMS Destiny casts off, heads back across the channel for the next Phoenix. By June 10th, the gooseberries are in place. Old ships scuttled as inner breakwaters. The first Phoenixes form the outer barrier. Assembly crews work on installing the whale roadways and Lobnitz pierheads. By June 17th, both Mulberry harbors are operational. Mulberry A at Omaha Beach, Mulberry B at Arromanches. Liberty ships navigate into the protected anchorages. Cranes begin transferring cargo. Trucks roll down the whale roadways carrying ammunition, food, fuel, medical supplies. The harbors work. 60,000 tons, 70,000. The numbers climb. The impossible has become routine, and on the beaches, Allied forces push inland, knowing supplies will follow. The logistics chain is secure. The invasion can continue, all because of concrete boxes that float. June 19, 1944, 2 a.m., Mulberry A, Omaha Beach. Commander James Patterson feels the wind shift. He's the senior engineer on duty at Mulberry A tonight, monitoring operations, coordinating repairs, ensuring the harbor functions properly. For the past week, it's been magnificent. Textbook operations. Ships unloading around the clock, supplies flowing. The Mulberry handling weather, tides, and the occasional German artillery shell without major issues. But this wind is wrong. Patterson checks the barometer. It's dropping, fast. Get the meteorology report, he tells his aide. The report arrives 10 minutes later. Patterson reads it again. Christ. A low-pressure system is developing over the Atlantic. Forecast, major storm. Duration, at least 3 days. Wind speeds, 30-plus knots. Wave heights, 10 to 15 feet, possibly higher. The worst channel storm in 40 years, and it's headed straight for Normandy. Signal all ships, Patterson orders. Secure for heavy weather. Suspend unloading operations. All small craft return to shore or to parent ships immediately. By dawn, the storm hits. 35-knot winds drive waves against the bombardon breakwater. The floating steel barriers buck and heave. Some tear loose from their moorings. Without the outer breakwater, waves attack the Phoenix caissons directly. Patterson stands in the operations center, getting damage reports every 15 minutes. Bombardon Section 7 adrift. Phoenix A-12 reporting stress fractures. Whale roadway connection failed at Joint 17. The Mulberry is being torn apart. Engineers work in impossible conditions. 10-foot waves crash over the Phoenixes. Rain lashes horizontally. The wind makes communication nearly impossible. Some Phoenix caissons crack. Water floods compartments that should remain dry. The massive structures shift on the seafloor. One Phoenix tips slightly, not enough to capsize, but enough that it no longer aligns with its neighbors. Gaps open in the breakwater. The whale roadways fare worse. The flexible joints, designed to accommodate tides, weren't engineered for storm conditions. Sections tear loose. Steel pontoons flip in the waves. Some sink. Lobnitz pierheads are battered against their anchors. One pier breaks loose entirely, drifting into another pier, causing a chain reaction of damage. By June 20th, Mulberry A is barely functional. By June 21, it's a disaster. Patterson watches from shore as waves destroy months of work. Engineers risk their lives trying to save equipment. Some succeed, many fail. A Phoenix breaks completely. The concrete structure cracks down the middle, floods, tips onto its side. A whale roadway section, torn loose, crashes into another Phoenix, damaging both. The storm doesn't care about engineering brilliance or strategic necessity. It just destroys. 30 miles east at Arromanches, Mulberry B faces the same storm. But Mulberry B has better positioning. The natural curve of the coastline provides some protection. The Phoenix caissons here are larger, more robust, and the assembly crews managed to complete more of the structure before the storm hit. Mulberry B survives, damaged, yes, some sections destroyed, but the core structure holds. By June 22nd, the storm subsides. Patterson surveys Mulberry A. The devastation is complete. The bombardon breakwater, destroyed. A quarter of the Phoenix caissons damaged beyond repair. The whale roadways mostly gone. The Lobnitz piers, wrecked. Can we salvage it? His aide asks. Patterson does the math. Repairs would take weeks, resources that don't exist. Time the invasion doesn't have. No, he says finally. We can't. Mulberry A is declared a total loss. The storm proved that nature doesn't care about human ambition. The engineering was sound. The design was correct. But when the channel unleashes its full fury, even the most brilliant engineering can fail. However, Mulberry B survived, and that changes everything. August 15, 1944. 10 a.m. Mulberry B, Arromanches. Colonel David Fraser stands on a Lobnitz pierhead watching the Liberty ship SS Thomas Jefferson unload cargo. Cranes swing pallets from the ship's holds to waiting trucks on the whale roadways. The process is smooth, practiced, efficient. Every movement choreographed, no wasted time. Fraser is logistics coordinator for the British Second Army. His job is simple: keep supplies flowing. Without supplies, armies stop. Without armies moving, the war stops. The Mulberry makes his job possible. Today's throughput? He asks his aide. As of 0900, 4,200 tons were on track for 7,000 by end of day. 7,000 tons every day for weeks now. Fraser pulls out his notepad. The numbers tell the story. Mulberry B daily operations. Average throughput 7,000 tons per day. Peak capacity 11,000 tons achieved July 31. Ships accommodated simultaneously, up to 18 depending on size. Operational time 10 months, designed for 3 months. Weather delays minimal. Harbor operates in conditions that would shut down beach operations. Comparison, August 1944. Daily tonnage, Utah Beach, 4,506 tons, supporting 7 divisions. Omaha Beach, 7,582 tons, supporting 12 divisions. Mulberry B, 7,000 tons, sustained Cherbourg, captured June 28, operational September. 13,500 tons at full capacity. The math is stark. Mulberry B, a temporary artificial harbor, is matching the output of beach operations while providing protection from weather. Fraser does long-term calculations. From D-Day through October 1944, total supplies landed through Normandy operations, approximately 2.5 million tons. Mulberry B's contribution, roughly 850,000 tons. That's 1/3 of the total, 1/3 of the invasion's logistical success coming from a harbor that didn't exist until June 9th. Fraser watches another truck roll down the Whale roadway loaded with artillery shells. Behind it, a medical supply truck, then fuel tankers, then food, 60,000 tons per day. That was the requirement. 10 divisions conducting active operations. The Allies are now fielding 30 divisions in France. The requirement has quintupled, and somehow the supply chain keeps pace. "Sir, signal from SHAEF headquarters," his aide says. "General Eisenhower is visiting tomorrow, wants a tour of the facility." Fraser nods. "Tell them we'll be ready." The next day, General Dwight D. Eisenhower stands on the same pierhead watching the same operation. "Remarkable," he says simply. Fraser provides the statistics, the tonnage numbers, the operational efficiency. The fact that Mulberry B has exceeded its design life by 7 months and shows no signs of failing. "The storm?" Eisenhower asks. June 19, 22, Mulberry A was destroyed. Mulberry B survived with damage. We salvaged components from Mulberry A to repair this one. Took about a week to get back to full capacity. Eisenhower looks out at the Phoenix caissons forming the breakwater. Some show damage, cracks, stress fractures. But they're still functional, still doing their job. "What was the German assessment of these structures?" Eisenhower asks. "Before the invasion." "Intelligence believes they identified them as anti-submarine barriers or harbor-blocking devices. They never understood the true purpose." "A failure of imagination," Eisenhower says. "They built the strongest coastal defenses in history, but they couldn't imagine we'd simply bypass the need for ports entirely." Fraser considers this. "The Atlantic Wall was impressive engineering, sir. Those fortifications were well designed, strong. The Germans did everything right from their perspective." "But they answered the wrong question," Eisenhower replies. "They asked, how do we make ports untakeable? We asked, how do we eliminate the need for ports? Better question, better answer." A Liberty ship sounds its horn, departing after unloading. Another ship is already maneuvering into position. "How long can this keep operating?" Eisenhower asks. "Unknown, sir. We're in uncharted territory. It was designed for 3 months. We're approaching 4. The Phoenix caissons are showing wear, but they're holding. The Whales need constant maintenance. But as long as we can keep it running, we will." "Good, because we're going to need it until we get the deep water ports fully operational. Cherbourg is improving, but it's not enough. Not for 30 divisions?" Fraser makes notes. "Understood, sir." After Eisenhower leaves, Fraser returns to his office. looks at the logistics charts covering the walls. The numbers don't lie. Without the Mulberries, the invasion would have been limited to what beach operations could handle. Maybe 20 divisions, maybe less. The breakout from Normandy would have taken longer, months longer. Perhaps it wouldn't have happened at all. But with Mulberry B functioning, supplies flow. Ammunition reaches the front. Fuel keeps tanks moving, food feeds soldiers, medical supplies save lives, all through a harbor that floats on water, assembled in 10 days, operating far beyond its design life. Fraser looks at one final statistic. The number that tells the whole story. Cumulative tonnage through Mulberry B, D-Day to October 1944, 850,000 tons. Cumulative tonnage through all Normandy operations, 2.5 million tons, 2.5 million tons of supplies, equipment, ammunition, fuel, vehicles, and everything else an invasion force needs. Landed on beaches that had no port facilities. Through weather that would have stopped conventional operations. Against defenses designed to make such operations impossible. The Atlantic Wall still stands, but it no longer matters. The numbers prove it. September 12, 1944. 3:00 p.m. POW camp near Southampton, England. Hauptmann Friedrich Weber sits across a table from Major William Thornton, British Royal Engineers. They're drinking tea. It's surreal. Two engineers, enemies by circumstance, colleagues by profession, discussing the war's greatest engineering projects. Thornton initiated this meeting. The British are interviewing captured German engineers, learning about Atlantic Wall construction techniques. Weber was identified as a specialist, someone worth talking to. The conversation has been professional so far. Technical, concrete formulations, reinforcement techniques, construction logistics. Now Thornton steers it somewhere else. The Phoenix caissons, he says. Your intelligence photographed them. What did you think they were? Weber sets down his teacup. Honestly, we weren't sure. The Abwehr assessment concluded they were submarine barriers, possibly devices to block captured ports by scuttling them in harbor entrances. You didn't consider artificial harbors? Weber shakes his head. No. The scale seemed wrong, the engineering too complex, and strategically... He pauses. We assumed you needed to capture ports. That assumption drove our entire defensive strategy. The Atlantic Wall. Yes, control the ports, control whether an invasion succeeds. It was logical. Every military textbook agrees. Amphibious invasions require port facilities. Thornton pulls out photographs. Aerial reconnaissance of Mulberry B in full operation. Ships unloading. Trucks on the Whale roadways. The Phoenix caissons forming the breakwater. Weber studies them. Even now, weeks after witnessing it firsthand, the audacity staggers him. When did concept originate? Weber asks. May 1942. Churchill proposed it. Most people thought he was mad. Engineers said it was impossible, but we kept working the problem. By September 1943, we had approval to proceed. Construction began October. 8 months, Weber says quietly. You built the components in 8 months. We spent 2 years on the Atlantic Wall. Different problems, different solutions. Weber looks at the photographs again. We built fortifications that could withstand naval bombardment. Direct hits from 16-inch guns, aerial bombs. We calculated every stress load, reinforced every weakness, created overlapping fields of fire. The defenses were scientifically designed. They were impressive, Thornton acknowledges. Some of the best military engineering of the war. But useless, Weber says. Because you changed the question we were answering. He sets down the photographs. We asked, how do we make ports impregnable? You asked, how do we eliminate the need for ports? We fortified positions, you mobilized solutions, we built to last 1,000 years. You built to last 3 months, except... He taps the Mulberry photograph. This is still operating, isn't it? Yes, far beyond its design life. Weber laughs. No humor in it, just recognition. I stood on that beach, he says. June 8th, watched the phoenixes being towed into position. I knew immediately what they were, and I understood. The entire Atlantic wall rendered obsolete, not destroyed, not overrun, just irrelevant. The fortifications still performed their function, Thornton says diplomatically. Your positions inflicted casualties, delayed our advance. For hours, maybe a day. At Omaha Beach, WN-62 held out longer than most until evening of the first day, then it fell. 14 resistance nests between Colleville and Vierville, all designed for mutual support, all fortified to resist sustained assault, all captured or bypassed within 24 hours. Weber stands, walks to the window. The British countryside is green, peaceful. Hard to believe there's a war happening across the channel. Do you know what the greatest failure was? Weber asks. Not the intelligence failure, though that was significant. Not the defensive design, though perhaps we could have done better. The greatest failure was imagination. He turns back to Thornton. We couldn't imagine you'd build your own ports. The concept was too audacious, too technically challenging, too operationally risky. Therefore, we dismissed it. We assumed you would do what we would do. Attack the ports directly, accept horrific casualties, hope to capture facilities before we destroyed them. And if we had? Thornton asks. Weber considers. You might have failed. At minimum, the invasion would have been far more costly. Dieppe demonstrated what happens when you attack fortified ports. If you'd tried the same at Cherbourg or Le Havre, the casualties would have been staggering. So the Mulberries won the war? No, but they made victory possible. Without them, you couldn't sustain the forces necessary for breakout. The invasion would have stalled. Perhaps you would have eventually succeeded, perhaps not. The Mulberries eliminated that uncertainty. Thornton makes notes. For the record, Hauptmann, what would you have done differently? If you could redesign the Atlantic Wall knowing what you know now? Weber thinks for a long moment. Nothing, he finally says. The Atlantic Wall answered the question we were asked. The failure wasn't in execution. It was in asking the wrong question. We defended fixed positions. We should have defended against mobility. We prepared for the enemy we expected. We should have prepared for the enemy capable of innovation. He sits back down. You know what's ironic? German engineering is famous for innovation. Tanks, aircraft, rockets. We pride ourselves on technical superiority. But in this case, you out-engineered us, not with better fortifications, with better thinking. The V-weapons, Thornton says, those showed innovation. Too late, too few, too ineffective. Weber waves dismissively. Resources poured into revenge weapons that barely impacted the war. Imagine if those resources went into mobile defenses, better intelligence, adaptive tactics, but no. We built concrete monuments and called them impregnable. The conversation continues for another hour. Technical details, lessons learned, mutual respect between professionals. As Thornton prepares to leave, Weber asks one final question. The storm, June 19th, it destroyed one of your harbors, yes? Mulberry A, complete loss. Did you consider abandoning the project after nature proved it was vulnerable? Thornton smiles. Consider it, of course. We lost 50% of our artificial harbor capacity. But Mulberry B survived, and that was enough. We salvaged what we could from Mulberry A, kept operating, adapted, while the Atlantic Wall simply stood there, unchanging, unadapting. Yes. Weber nods slowly. That's the lesson, isn't it? Not that your engineering was superior, though it was brilliant. The lesson is that you remained flexible. You built for adaptation. We built for permanence. In modern warfare, adaptation beats permanence. I'll include that in my report, Thornton says. After the British officer leaves, Weber sits alone in the room. 2 years of his life spent on the Atlantic Wall. Calculations, designs, supervising construction, creating defenses that were supposed to be impregnable. And they were impregnable. That's the bitter joke. The bunkers still stand. The guns are still operational. The fortifications are exactly as designed. They just don't matter, because the Allies brought their own ports. October 1944. Arromanches, Normandy. The war has moved inland. German forces are retreating toward the Rhine. Allied armies pursue. The front is hundreds of miles away now. But at Arromanches, Mulberry B still operates. Captain Robert Harrison, the tugboat captain who towed the first Phoenixes across the channel, stands on the beach. He's been reassigned. Mulberry operations are routine now. Other officers handle daily coordination. Harrison is here for personal reasons, to see the thing he helped build. The Phoenix caissons stretch along the horizon, concrete giants partially submerged forming the breakwater. Even now, 4 months after the storm, they show damage, cracks, stress fractures. One Phoenix lists slightly, no longer perfectly aligned, but they're still there, still functioning, still protecting the harbor. A Liberty ship maneuvers toward a Lobnitz pier. The Whale roadway connects pier to shore, rising and falling with the tide. Trucks roll down the roadway carrying supplies. The system works. Harrison walks along the beach. Low tide exposes the bases of some Phoenix caissons. He can see where concrete met seafloor, where engineering met reality. A local French woman approaches. She's maybe 60, wearing black, carrying a basket. "You are English?" she asks in accented English. "Yes, madame." "You helped build this?" She gestures at the Mulberry. "I towed some of the pieces across the channel." She looks at the structures. Before the war, this was a quiet beach. My grandchildren played here, built sandcastles. Then the Germans came, built their guns, their bunkers. The beach became death. She pauses. "Now you build this, and it brings life. Food, medicine, liberation." She looks at Harrison. "Thank you." She continues down the beach. Harrison watches her go, thinks about what she said. The Germans built for death. The Allies built for life. That's perhaps the truest summary. The Atlantic Wall was designed to kill, to stop, to deny. Every gun position calculated for maximum casualties. Every obstacle placed to cause maximum damage. Every mine intended to maim or destroy. The Mulberries were designed to sustain, to supply, to enable. Every Phoenix positioned to protect. Every Whale roadway engineered to facilitate. Every ton of supplies intended to support the forces fighting for liberation. 2 engineering projects, 2 philosophies, 2 outcomes. Harrison turns toward the Phoenix caissons. They'll stand for decades, he realizes. Long after the war ends, the concrete won't erode quickly. These structures will remain as monuments, not monuments to war, monuments to problem solving. The Germans asked, "How do we stop them?" The Allies asked, "How do we succeed despite them?" Better question, better answer. June 8, 1944, 9:23 a.m. Arromanches, Normandy. Hauptmann Friedrich Weber stands on the beach watching the Phoenixes cross the channel, hands behind his head. Prisoner of war, engineer who spent 2 years building the Atlantic Wall's fortifications. Around him, other prisoners watch the same spectacle. Most don't understand what they're seeing. They see concrete structures, large ones, being towed by tugboats. Weber sees the end of an era. For millennia, warfare followed certain principles. Control the high ground, fortify key positions, deny the enemy access to resources. The Atlantic Wall embodied those principles perfectly. 15,000 fortifications, 4,000 kilometers of coastline, the strongest coastal defenses in history. All predicated on one assumption: the enemy needs ports. And now, before Weber's eyes, that assumption is being demolished. Not by superior firepower, not by overwhelming numbers, by engineering that thought differently. The British Guard notices Weber staring. "Impressive, innit?" the guard says. "Biggest engineering project of the war, that. Took 8 months to build. Probably take 8 hours to get your lot to surrender if you'd known about it earlier." Weber doesn't respond. Can't respond. His throat is tight. He thinks about Jean-Pierre Rousseau, the French mason who mixed concrete for WN62, wonders if Jean-Pierre is alive, wonders if he watched the fortifications fall, wonders if he feels vindicated, 2 years of forced labor rendered meaningless in a day. He thinks about Field Marshal Rommel's confidence. They will die on the beaches. Absolute certainty, based on impeccable logic, wrong logic, but impeccable. He thinks about Hitler's directive. Frantic energy, 15,000 bunkers, built with frantic energy, still standing, still strong, still irrelevant. Another Phoenix caisson moves past, towed by 3 tugboats. It rides low in the water, gray and massive, heading toward its position in the breakwater. Weber does calculations automatically. Can't help himself. He's an engineer. Displacement, approximately 4,000 tons. Dimensions, roughly 60 meters by 18 meters by 18 meters. Concrete volume, probably 12,000 cubic meters. Reinforcement, substantial. Has to be to survive towing. That's equal to a major gun battery casemate, the same amount of concrete Germany poured into Battery Lindemann's gun positions. But the Phoenix moves, can be positioned anywhere, can create a harbor where none existed. The gun batteries are fixed, immobile, tied to specific positions, mobility versus permanence, adaptation versus fortification, the future versus the past. "All right, Fritz, time to move," the British Guard says. "Long walk to the processing center." Weber takes one last look at the channel, at the Phoenix's crossing, at the engineering solution that defeated 2 years of his work. In that moment, he understands something fundamental. Germany lost this war before it started, not because of resources, though the Allies had more, not because of manpower, though the Allies had more of that too. Germany lost because they asked how to be stronger. The Allies asked how to be smarter. The Atlantic Wall stands today. Tourists visit the bunkers, photograph the gun casemates, marvel at the concrete thickness, the engineering precision, the intimidating presence. The fortifications are exactly as designed. 6-foot walls, reinforced ceilings, firing embrasures with perfect fields of fire, impregnable and obsolete. At Arromanches at low tide, the Phoenix caissons are still visible. Concrete structures settled into the seafloor 70 years ago. Weather-worn, damaged, but still there. They weren't designed to last. 3 months, maybe 6, then they'd be abandoned, dismantled, forgotten. Instead, they operated for 10 months, moved 850,000 tons of supplies, sustained armies, enabled victory. Then, when they were no longer needed, they simply stayed. Too massive to move, too expensive to demolish, so they remain as monuments. The Atlantic Wall was built to last 1,000 years. The Mulberries were built to last 3 months. The Atlantic Wall still stands, empty and useless. The Mulberries are gone, but their impact won the war. One designed for permanence, the other for purpose. History remembers purpose. The Germans built a fortress. The Allies built a solution. And 2.5 million tons of supplies, weapons, ammunition, vehicles, food, and equipment flowed through holes in the water where harbors shouldn't exist. The graveyard isn't just for the Atlantic Wall. It's for the entire concept that strength alone wins wars. The Allies proved something different. Engineering, creativity, adaptation, logistics, these win wars. Not bigger walls, better thinking. The Atlantic Wall was impregnable. It also didn't matter. And that's the most devastating defeat of all.